So I'm here at Konkoly Observatory on the hills of Buda in Budapest with Robert Szabo, who is the director of the observatory, Konkoly Observatory, and also an observational astronomer. And Robert, did I get the pronunciation of the name correct? Is that close? How do you pronounce that?
Yeah, it's Robert Szabo. I spent 2 years in the US and I always had trouble with that SCABO, Mr. Szabo or Szabo, Szabo, everything, whatever. Yeah, it's an S, Szabo.
And we've been talking about a ongoing observational program to look for minor impactors, and your observatory has discovered 3 of only 9 minor impactors that have impacted Earth, and since when we don't really know. I mean, for time immemorial, people have observed meteors, but we've had no warning time. And this is the first time, if I'm not incorrect, that you have had a program that is looking to identify minor impactors on down to 1 or 2 meter in size, probably on up to the largest ones you could have identified that aren't already identified by somebody else would be, what, 200 meters, 250 meters, something like that. Is that correct?
Yeah, that's right. Yeah. For the first time in history, now we can predict these impactors.
And is it true that it's a 60 centimeter telescope on top of the mountain whose name, can you pronounce that for me?
Yeah, it's at Piszkéstere mountain station, Piszkéstere Observatory, some 80 kilometers from here in the Matra Mountains.
In the Matra Mountains, right. Where you have 2 or 3 other telescopes, but
yes,
you're dedicated there on every clear night looking for potential Earth impactors in this size range. And let me just clarify, what we're talking about is you are looking to give some warning to Earth, an hour or 2, maybe 6 hours, maybe 12 hours of warning that potential impactors are heading, where they're heading geographically, to provide the citizens with warning. Of course, 70% of Earth is water, so we're not really. Most of the impactors don't hit land, but
even some of them are exploding before hitting the Earth. So only tiny fragments can be found as meteorites. And actually, this is just a side effect, because we are looking for NEOs, near-Earth objects that come close to the Earth. And as a bonus, some of them turns out to be on an imminent impact trajectory. So that's when things become really interesting, and we can issue a warning.
But to be clear, only 9 impactors have been identified before impact. That seems incredible, but am I wrong in saying that?
No, that's the number 9 so far up to today. And out of these 9, 6 were found in the US through big sky surveys, and 3 from Hungary. So we are a big power kind of in this niche area.
In the US, you had the Pan-STARRS in Hawaii.
Pan-STARRS and Atlas, big sky surveys, right?
And also, is the Atlas on Mount Lemmon? Is that?
Yeah. Actually, they have more than 1 telescopes throughout the globe.
Okay, but you are at the right longitude, you tell me, to look for these objects in Eastern Europe, and explain what you mean by that.
Exactly, because it's not only about clear skies, but you have to be on the right place in the right time, because these impactors will leave us only a few hours before they impact. So you have to be able to see it during nighttime, and that's why it does matter whether you are in Hawaii on the other side of the globe, or in China, or in South Africa, or South America, or the Canary Islands, wherever big telescopes and big survey telescopes are located. So, but on this longitude in Central Europe or Europe and Asia, actually it looks like that Hungary and Piszkéstere Observatory, Konkoly Observatory has a special place, and we are not aware of any other similar large ongoing surveys that are looking for NEOs or impactors. So that's why we have a very special location here. So we are ahead of America, and we are after the night in Asia. So if it's during the night in Europe, then we are in the right place, and then we have a chance to see those first.
So you're filling a niche that hasn't been filled. And this is important because these smaller impactors, we were talking about the 2013 Chelyabinsk impact that that exploded over Chelyabinsk, Russia, I believe.
Right.
And I don't have, off the top of my head, I think it was a 13 meter. I'm not certain, I had to look that up, but neither one of us can remember the exact diameter of this
don't really
impact.
know for
It's an estimate.
sure. That's an estimate.
Estimated. But even an object that's relatively small that explodes in the atmosphere can cause a lot of damage, as that one did.
Yeah, the Chelyabinsk one was a bit bigger than these impactors that we found before the impact. So like a 10 meter, a 20 meter can already cause some damage. If nothing else, but the shock wave, the pressure wave will broke your windows. And that's what happened exactly in Chelyabinsk in Russia in 2013. The smaller ones, 1 or 2 meters in size or a bit bigger, they will almost completely destroyed, and only the tiny small meteorite fractions will hit the Earth. These do not really cause any damage. It's a nice phenomena. You go out, it's nice sky, and you see a huge explosion, just like it's brighter than can be brighter than the full moon, and it's a once in a lifetime kind of event. And the pretty nice thing is that we can now predict it.
But in theory, if your work continues, you want to add 3, maybe 4. You want to add maybe 2 or 3 more 60-meter telescopes on the mountain here in Hungary to continue your observations. And this would not only protect Hungary, but we're talking all of Europe, correct?
Exactly. Most of them, what we are seeing as on a imminent trajectory orbit, will explode over Western Europe. Yeah, that's from the nature of the geographical location.
And ESA, the European Space Agency, already has a planetary defense office,
Right.
and you have applied to become part of their planetary defense network. Is
Yeah,
that correct?
we are doing negotiations right now, and we would like to expand our network.
In theory, to wrap it up, the bottom line is that you hope this is also good for science to learn about the early formation of the solar system, because you don't really know where these objects originate. They could be broken off material from smaller, dwarf planets like
Exactly.
Ceres or even large Mars meteorites. You're telling me.
Exactly. That's we now have a chance to find those objects that hit the Earth and take them into laboratory, and not only seeing them through telescopes. So we have a chance to investigate them in detail. And there's another factor I should mention, that it's very exciting for the general public when we are talking about such huge explosions. A lot of people see those. They are able to go out even during night. They get a message, an email, or an internet warning, and they can see by themselves. And this is a huge plus, because the general public is very much interested in science, in astronomy, and it's an easy way to make them,
More aware,
and more.
or they could even take
engaged.
shelter. I guess if they
Hopefully,
had to.
yeah. That's if there's something that would really threaten our planet, then we should have an early warning, and we are working on that.
And this is not an expensive project. I mean, what is your annual budget for this one survey?
So the survey itself goes from the observatory's budget, so our institute budget, but to upgrade this system, we did it in 2016. We got a €1 million sort of money, or 2 million euros actually, and that enabled us to buy a huge CCD camera, a huge detector that was put into this telescope, which already has a big field of view, but you know, the CCD cameras are usually much smaller than what you are holding in your hand. It has a very small, it covers only a very tiny
Right.
area, so we need a big one, the biggest one that was available on the market. We bought it, so that was a dedicated project. We bought this huge CCD. It took a few years actually to custom build things, and then a few years ago this whole upgraded system could start its work. So,
And that was a grant from the European Union?
that was a grant partly from the European Union, partly from Hungary. Yes,
Partly
exactly.
from Hungary, okay. But Hungary now is a part of the European Union.
It is, yeah, it has.
And,
we have been.
okay. So thank you so much, Robert, for your time today. Good luck with this in the future, and we look forward to hearing about this, your upgrade on down the line.
It was my pleasure. Thank you very much.